Isaac Newton. A name that resonates through the annals of scientific history. The name conjures images of falling apples and groundbreaking discoveries. We often picture him sitting under an apple tree, the moment of inspiration striking as the fruit falls to the ground. But there's more to this scientific icon than meets the eye. Beyond the well-known anecdotes lies a man of profound intellect and complex character. Newton, the father of classical physics, was a man of contradictions and hidden depths. His contributions to science are monumental, yet his personal life remains shrouded in mystery. He was a solitary genius who revolutionized our understanding of the universe. His work laid the groundwork for many scientific advancements that followed. He was also a secretive alchemist obsessed with ancient texts. Newton spent countless hours in the dim light of his study, poring over alchemical manuscripts, searching for the philosopher's stone. We know him for his laws of motion and universal gravitation. These principles form the bedrock of classical mechanics and have stood the test of time. But few realize the sheer breadth of his genius. Newton's curiosity knew no bounds, and his intellectual pursuits spanned a wide array of disciplines. Newton's inquisitive mind delved into mathematics, optics, and even theology. His work in optics, for instance, led to the groundbreaking discovery of the nature of light and color. His work laid the foundation for modern science. The principles he established continue to influence scientific thought and experimentation to this day. He unlocked the secrets of light and color. Through his experiments with prisms, Newton demonstrated that white light is composed of a spectrum of colors. He developed calculus, a powerful mathematical tool still used today. This invention alone has had a profound impact on fields ranging from engineering to economics. Newton's story is not just about scientific breakthroughs. It's a tale of relentless curiosity and an unyielding quest for knowledge. It's about a relentless pursuit of knowledge. Newton's insatiable thirst for understanding drove him to explore the unknown and challenge the accepted norms of his time. It's about a mind that dared to venture beyond the accepted truths of his time. Newton's willingness to question and investigate set him apart from his contemporaries. Join us as we journey into the life and mind of this enigmatic genius. We'll explore the lesser-known aspects of his life and uncover the man behind the legend. We'll uncover the man behind the myths, the human behind the legend. Newton's legacy is not just in his discoveries, but in his enduring influence on the world of science. The story of Isaac Newton is a testament to the power of human curiosity and the endless pursuit of knowledge. Isaac Newton's contributions to science are immeasurable. He didn't just discover laws, he redefined our understanding of the universe. Imagine a world without the concept of gravity, a world where the motion of planets remained a mystery. This was the world before Newton. His laws of motion explained the relationship between force, mass, and acceleration. These laws govern the movement of everything around us. From the swing of a pendulum to the orbits of planets, Newton's laws provided a unifying framework. Then there's his theory of universal gravitation. This groundbreaking idea explained the force that holds the planets in orbit. It showed that the same force that pulls an apple to the ground also governs the celestial dance of planets and stars. Newton's impact extends far beyond physics. His work in optics led to the development of the reflecting telescope. His mathematical breakthroughs paved the way for calculus, a cornerstone of modern science and engineering. Isaac Newton's life began in uncertainty. Born prematurely on Christmas Day, 1642, in Woolsthorpe, England, he was a small and frail child. His early days were marked by a struggle for survival, as he was not expected to live long. The harsh winters and limited medical knowledge of the time only added to the challenges faced by his family. His father, a farmer, died just 3 months before his birth. This left his mother, Hannah, to fend for herself and her newborn son. The loss of his father before he even had a chance to know him was a shadow that loomed over Newton's early years. Young Isaac's survival was far from guaranteed. His mother, Hannah, was determined to see him thrive despite the odds. She did everything in her power to ensure he had a fighting chance, even as she faced her own grief and the challenges of single parenthood. When Isaac was just 3 years old, his mother remarried, leaving him in the care of his grandmother. This separation was a pivotal moment in his young life. The absence of his mother during these formative years left a deep emotional scar. This separation deeply affected Newton. He often felt abandoned and isolated, feelings that would shape his personality and drive his relentless pursuit of knowledge. The loneliness he experienced as a child became a constant companion throughout his life. It instilled in him a sense of loneliness that would follow him throughout his life. This solitude, however, also became a source of strength. It allowed him to focus intensely on his studies and his thoughts, free from the distractions of a more social existence. Despite a difficult childhood, Newton showed early signs of intellectual curiosity. He was fascinated by the world around him and spent hours reading and experimenting. His inquisitive nature set him apart from other children his age. He excelled in school, demonstrating a keen interest in mathematics and mechanics. His teachers quickly recognized his potential and encouraged him to pursue his studies further. Newton's academic prowess was evident from a young age, and he soon outpaced his peers. At the age of 19, he entered Trinity College, Cambridge. This was a significant milestone in his life, marking the beginning of his formal education in the sciences. The environment at Cambridge was intellectually stimulating, providing Newton with the resources and mentorship he needed to flourish. Little did he know that this would become the launchpad for his extraordinary journey. At Cambridge, he was exposed to the works of great thinkers and began to develop his own theories. His time at the university was transformative, laying the groundwork for his future discoveries. However, the tranquility of university life was soon disrupted. The Great Plague swept across England, forcing the university to close its doors. This unexpected turn of events could have derailed Newton's academic pursuits, but instead, it led to one of the most productive periods of his life. The Great Plague swept across England, forcing the university to close its doors. Newton returned to Woolsthorpe, where he spent the next 2 years in relative isolation. This period of solitude proved to be incredibly fruitful for Newton's intellectual development. Newton returned to Woolsthorpe, where he spent the next 2 years in relative isolation. Away from the distractions of university life, he had the freedom to think deeply and experiment. It was during this time that he began to formulate some of his most groundbreaking ideas. It was during this period of forced solitude that some of his most revolutionary ideas began to take shape. The isolation allowed him to focus intensely on his work, leading to the development of theories that would change the course of science forever. Newton's early life, marked by hardship and solitude, set the stage for his remarkable contributions to the world. Section 4. The Apple, the Moon, and the Force of Gravity. The story of Newton and the apple is the stuff of legend. It has been told and retold through generations, often with a touch of embellishment. Yet, at its core, it holds a kernel of truth that has shaped our understanding of the universe. While likely embellished over time, it holds a kernel of truth. The tale goes that Newton was sitting in his garden when he saw an apple fall from a tree. This seemingly mundane event sparked a profound realization in his mind. Legend has it that Newton, sitting in his garden, observed an apple falling from a tree. This simple observation led him to ponder the forces at play. What was it that caused the apple to fall straight down to the ground? This seemingly mundane event sparked a profound realization. Newton began to wonder if the force that pulled the apple to the ground was the same force that governed the motion of celestial bodies. He wondered, if an apple falls to the earth, could the same force that pulls the apple also extend to the moon? Could this force be responsible for the moon's orbit around the earth? This simple question led to one of the most important scientific discoveries of all time: the theory of universal gravitation. Newton's curiosity and his ability to ask profound questions set the stage for a revolutionary understanding of the natural world. Newton realized that every object in the universe attracts every other object with a force proportional to their masses. This force, which we now call gravity, is what keeps us grounded on Earth and governs the motion of celestial bodies. This force, gravity, is what keeps us grounded on Earth. It is the invisible hand that holds the planets in their orbits around the Sun and dictates the motion of galaxies. It's what governs the motion of planets around the Sun. Without gravity, the universe as we know it would not exist. Planets would not orbit stars, and galaxies would not hold together. Newton's genius lay not only in identifying this force, but in developing a mathematical framework to describe it. His laws of motion and universal gravitation provided a precise way to calculate the gravitational force between any two objects. His law of universal gravitation provided a precise equation to calculate the gravitational force between any two objects. This equation, which states that the force is proportional to the product of their masses, and inversely proportional to the square of the distance between them, revolutionized our understanding of the cosmos. Newton's work laid the foundation for classical mechanics and influenced countless scientists who came after him. His insights into gravity not only explained the motion of objects on Earth but also the motion of celestial bodies, bridging the gap between terrestrial and cosmic phenomena. Today, Newton's laws continue to be a cornerstone of physics. They are used in everything from predicting the orbits of satellites to understanding the dynamics of galaxies. His legacy endures, reminding us of the power of curiosity and the profound impact of asking the right questions. Ushering in an era of reason and enlightenment.